All right. Hello, everyone. I'm Professor Caudill, and I think we left off on prototypes last time. So probably around here. So the authors are talking about. I mean, this is kind of a relevant thing. Tutor agents. So tutoring agent to teach elementary physics. So terms of knowledge. So what's the problem here? As we saw, even large language models cannot really solve problems in the physics domain. The problem with the large language model is it can't take words like north of west and understand that's the second quadrant of a Cartesian graph. So, in other words, this is a lot easier said than done. Um, I wish they would have used like examples that are more realistic. This is very speculative, and we have direct experience with large language model capabilities here. Um, I guess I guess the example is like what would you label as prior knowledge? Okay, so past experience. So this is very student oriented, but it's not. Um, it's really on the prior knowledge that is it prior knowledge? It's like how does the agent know the subject? Um, so yeah. Next we have like a trading agent interacts with the information environment. I personally don't care about trading agents. I'm either looking for like agents that extend, improve life extension, like they help build life extension technology. That's the thing I would like to build. I probably need to build like simpler agents before, just to learn how to do everything. Smart home looks after itself, inside out robots. So I wonder, I haven't really seen that term before. Senses people. So basically, this is the biggest thing is just adjusting lighting and heat. Smart home just adjusts lighting and heat. So it senses when people are in the house, and then or it can predict when the person gets home based on like activity, and then it can change the temperature. So I haven't seen anyone with robots and action and any robot arms to help with kitchen. This is very speculative so far. So this kind of makes me wonder what the rest of the book will be like. Um, Okay, yeah, so I don't know. I don't really find this incredibly useful. Let's just move on. Agent design space. Agents acting in environments. Okay. Again, I know you guys can read, so I'm trying to pick out what I agree or disagree with, or I find interesting. So designing AI modularity. Modules that be understood separately. Okay, so we can just write AI is the sum of modules. Or we can just write the integral of modules. I know it's in the definition, but it's the integrated sum. So maybe we should. Do I just write? I think you get the point here in the pseudo math. It's the sum of the models, or it's the integrated sum of models. Whatever, however you want to look at it. So modularity, reduce complexity. Okay. Flat, modular, or hierarchical. Okay. So, the modules. Uh, each module is it's kind of like a branching tree of components. Okay. Okay. I've heard of object-oriented. I haven't heard of procedural abstraction. Procedure. Object-oriented programming. Planning, a finite horizon planner is an agent that looks at a finite number of stages, except for an indefinite time, but not predetermined number of stages. Okay, so this seems important. Representation dimension and concerns how the world is described. State of the world is its internal state and environment. Again, this is like a Western view of looking at it. Yeah, I mean, I wish they just add like AC to this, so they'd just be like, okay, if it's hot, turn on AC, turn off thermostat, or turn off the heating. If it's cold, turn off AC, turn on heating. You know, that would just make more sense instead of just doing a one-sided. Uh, Proposition, Boolean feature. It may be easier to specify and reason with 30 propositions than with a billion states. It's kind of it's kind of an interesting claim. I wonder what they mean by a compact representation of states. Recognize digits. Okay, so this is applicable to us. Observes a binary image on a 28 handwriting recognition systems define features of the image, line semantics define functions of image. Okay, I do want to see this example. Um, Modify National Institute of Standards. Say data set of grayscale images. %98.4%. Um, let's move on. Features can depend on relations and individuals. Okay, so basically, most complex is states. States. Okay. So you really want to be working at, I'm sorry, this should be the other way. So you really want to be working at the relations level. So for us, what's the relation if we're like making that video game AI? What's the relation of um, health to I don't know, movement? Between movement and not moving. Uh, Computational resources, limit time. Okay, so this is kind of obvious, but I guess it's important to state it. So this is like memoization with like Fibonacci numbers. The delivery robot cannot think for a long time about how to avoid a person. Solution quality as a function of time for any time algorithm. Learning dimension determines whether knowledge is given or knowledge is learned. So I'm kind of burnt out of reading. I kind of just wanted to get some hands-on stuff. So I might go a little faster if that's all right with you guys. Okay, yes, design agents. I want to design an agent. I'm tired of reading. An AI representation typically says when you know how it. Ask, solve, solution. Okay, so we're going this way. Task, we represent it. We compute the representation. Interpret this output to get a solution. Task solve. Don't really like that figure. All right. Review the book. Okay. Okay. I'm ready to move on. Um, physical symbol. System manipulates symbols determined to do. So we need to represent a task. Okay, is it gonna like show me how to do anything? I want to make an AI. Want to learn by doing. Does this textbook tell me how to code? Tell me how to. Okay, yeah, it's kind of just like it's weird. It's like weird flex what they're doing right now. Um, breadth first search. I've seen this term before. And there's like an opposite. You can go from so you can go from top down or bottom up. I think good models probably use like a combination of both. So depth first doesn't really explain it that well though. Yeah, I'm not a fan of this book. It's 2 to the 10, so 1 million, so 1,000, 1 million, 1 billion, million, billion, trillion, thousand, million, trillion, thousand, million, trillion. I'm not like overwhelmed by the math. It's just I want to like put stuff into the Jupyter notebook. It's like, okay, there, listen, let me explain why this book. There exists a world where Professor Caudle is an expert on building AI. Okay, so there exists a world where this is true, and right now we are not there. So we need to find the shortest path. So find shortest path there. Okay. So what's one of the shortest paths? Man, is it drilling basics? Is it drilling? So we have option. Let's say options, drill basics. Simple programs. Okay. So we could do simple models. This book has not given us any simple models, or it hasn't given us the Python code for a simple model. So dates, okay. Variables or features. So this might be if I've learned anything so far, it might be this. I think one of my first videos on this book, I kind of wrote like a design of a light bulb, like the circuitry of it. It's like one, zero and ones and states. So it's saying that's not efficient. It's more efficient to say the light bulb is a set of variables for the state. The val There's a val at position 2. See, this is wrong because in computer you notate positions. It's kind of it's a little off tuition, but the C here is 0, A is 1, T is 2. So if you're saying there's a val in position 2, it would be saying T is that. So that's just like bad pseudo programming. Um, I don't really care about Leibniz at the moment. Drill basics, build simple models to okay, so not P. So it's like okay, so what I'm not totally familiar with is the XOR. I think it's just I wonder if they actually show us the truth tables. Probably not, but in actual textbooks with these logical formulas, they'll do um, they will do truth tables. They'll show you all the possible states, but apparently we don't need to know states. We just need to know variables and relations to be more efficient. Okay, so here we are showing truth tables. So I think we learned in like the first video, KB satisfies G, or G satisfies KB. I know this is probably important, but I'm trying to drill the basics. I'm trying to become an expert as fast as possible. So I need to be building things now. Don't have time to read. We are in a hurry. Time is ticking. Clock is ticking. I don't have time to read. I don't like this definition of ontology. Ontology is really the nature of being, the philosophy of beingness. I would probably say the meaning of symbols is probably like lexical semantics or something. Okay, are we going to build anything, or is it just going to kind of beat around the bush? A lot of words, nothing really of great value in this book so far. You know, I'm here to learn. I'm not here to waste my time. Okay, so maybe we can do something here. 5 chapters till we can actually learn something. Um, okay. So yeah, I can get AI Python. Let me AI Python. What is this thing? AI Python. Python code for oh, so this is actually made by them. Oh, it's not even free software. That's awesome. Mm, licenses. Published software should be free. You need to release it under free license. GNU. Okay, so their software is you're free to copy, redistribute. Must indicate what changes were made. Cannot use it for commercial purposes. Okay. Is a isn't considered compatible. Cars that any derivative works that are also distributed under GPL. So the non-commercial clause is kind of an issue. I use MIT license a lot. Okay. This is a non-copyleft license. It's good for art entertainment and educational works. It is compatible with all versions of GNU. However, it should not be used on software. Interesting. Um, wish I could make it so you guys can see this. Okay, so CC by NC. So it sounds like CC BY is a bad license for this textbook, so that means we have to find a new textbook because I'm not using a non-free. They said this should not be used on software. Okay. So we recommend against using Creative Commons licenses for software. Encourage you to use one of the very good software licenses are available. It's one way. Okay, so basically this book is inadequate for our so yeah. Kind of sucks. We have to find a new textbook now because we need free software. We need a list. What's the list of I wonder where MIT is on this. Okay, so we need a textbook with AI textbook with GNU software. We're about out of time. No longer in print. Okay. Um, all right, so this is what it's come down to. I don't think we can use this. This is not good for us. Don't like this license for this textbook, so we have to find a new textbook. So yeah, I'll see you guys next time, and hopefully we have a new book to look at that actually is aligned with our path. So I'll see you next time.